Hello. All right, getting started on Algebra 1, Unit 2, Lesson 6. So today we're going to talk about some linear functions, and I have a few graphs here for you. I've got in the yellow x squared, which is a parabola, basically a U shape that kind of goes up and outwards as it continues on. It continues on upwards and outwards here. Mine, for whatever reason, looks kind of more like a V, but it's supposed to look more like a U. And then g of x is the absolute value of x. This straight up looks like a very wide V. These are two diagonal lines that kind of meet here. It bends at the origin, creating a 45-degree angle kind of in both of the quadrants there. And then this red one is negative x minus 1, h of x. And you see it just basically slices down the graph. And here is a fancier one using Euclid's number. And you can see it's creating this kind of gentle S-curve or slope. Only one of these is a linear function. They're all functions, but only one is a linear function. So out of all the many different kinds of functions we can look at, today we're going to focus on linear functions. And that's this red one, the one that looks just like a straight line, no curves and no bends. Okay, so we're going to focus on functions that when they're graphed look like straight lines. Now, here's some examples of just different ways you can write the equations for a linear function. Equations, are written with y instead of f of x. So you have here y equals 2x plus 1, or 5x equals 6 plus 3y, or y divided by 2 equals 3 minus x. These are all valid linear equations. If one thing I want you to notice with linear equations is that they don't have any kind of a higher power on their variables. There's no squares or cubes or anything like that. Okay, so linear equations generally will have an intercept, and what an intercept is somewhere where the graph of the linear equation crosses an axis. So here we have a coordinate plane, and you have the x-axis and the y-axis, right? And if we were to pretend to graph a line, say we pretended to graph this line right here, it crosses both the x-axis and the y-axis. This particular point where it crossed the x-axis is called the x-intercept. And this particular point where it crosses the y-axis is called the y-intercept. Okay, now not every line crosses both of these. You can have lines that cross just the x-axis. That's a straight up and down line. You can have lines that cross just the y-axis, and that is just a horizontal line, right? Vertical line and a horizontal line. So I can't think of a line you would ever have that doesn't cross any axes, but you will at least cross one, usually two. So there's another depiction of an x-intercept. And here is an x-intercept and a y-intercept. If you notice, when you find the y-intercept, the only thing that will have a number in the ordered pair is the y value. The x value will always be 0. And that's because we want it to be on the y-intercept or y-axis. And the only way that it can be on the y-axis is if it doesn't move to the right or to the left horizontally at all. So x can't move. It has to be 0 in order to have a y-intercept. And the same goes for the x-intercept. The y spot always has to be 0 because it can't move up or down at all if it's going to be on the x-axis. So the y in an x-intercept is always going to be 0. And when you have an x-intercept, the only thing that will have value is going to be the x location or the x coordinate of the ordered pair, okay? All right, so here we have 4 questions. I want to go ahead before you pause it, and we're going to just go over what number 1 is, and then you can pause this and do 2, 3, and 4 on your own. So we're supposed to write what the ordered pair for the x-intercept and the y-intercepts are. So here's the x-intercept. And I know for an x-intercept, my y will always be 0. X-intercept is 1, 2, and the negative direction, so -2. Y-intercept, I know if I've got a y-intercept, my x value is always 0 and I'm looking for the y. And that is a positive 2 because I went up 2. Now that's assuming these are 1, 2, 3, etc. 1, 2, 3, which they aren't numbered on this particular graph, but the rest of them are, so it should be easy enough for you to do. So go ahead and pause the video, do questions 2, 3, and 4, and then come back when you're done. All right, welcome back. Here we have let's start with the y-intercept. The y-intercept, remember the x is going to be 0 and the y is at 0.1. So that was easy enough. Now here, the x-intercept, I know that my y value is going to be 0, but what's my x value? It's halfway in between 1 and 2. Well, that's not an integer, but you don't have to always have integers on a graph. It can be just a real number. So this real number happens to be 1.5 or 1.5. Many times people prefer reduced improper fractions, so 3/2 in this case. All right, number 3, let's look at this one. That's going to have an x value of 0, y value of 4. Here is going to have a y value of 0. I always put in my zeros first. It helps me remember. If I'm looking for an x-intercept, I only want to be looking for the x coordinate, okay? So that's just my habit. So here we have, okay, this is again the x-intercept. It's the first time the x-intercept happens to be higher than the y-intercept. That's interesting. So here we go. The x-intercept means my y is going to be the 0 and my x is 6. Here is the y-intercept, which means my x is 0 and my y is -3. So did it matter if one was higher than the other? No, it just kind of meant my y-intercept was going to have a negative number. So if you notice, it doesn't matter if it's one direction or the other. You just have to make sure to include any signage, just like you would any other point that you're finding on the coordinate plane. And here are some additional, more well-written, easier to read answers for you if you want to pause and make sure you can read that and write it down in your notes. All right, so linear equations intercepts. In addition to finding an intercept by looking at the graph, you can also use it by putting it into the equation. So here we have an equation, 4x minus 1 equals 3y plus 5. Now, I told you, remember when we were looking at the graph, let's say these are our intercepts right here, our line kind of goes like that. This intercept, this x-intercept is always going to have a 0 in the y spot. And this y-intercept is always going to have a 0 in the x spot. So what does this mean for us with an equation? Well, this means that we can figure out what the intercepts are by plugging in zeros strategically. By plugging in, that means to do that special math word called substitution. Just like in a football game, if somebody gets injured and you want to substitute a player, you're going to stick a different player into that same position. So here, what we're going to substitute, let's start with substituting for our x. If we're putting a 0 in for our x, we are going to find out what a y value is. So we're looking for our y-intercept. And again, this is not how you spell intercept. That just happens to be my abbreviation for it. If you want correct spelling, make sure you look at the full written out word. All right, so 4 times 0 minus 1 equals 3y plus 5. Okay, I plugged in or substituted 0 in the place of the x because my y-intercept, I have a 0 in the x location. 4 times 0 is 0. So that's going to leave me with -1 equals 3y plus 5. I want to move this 5 to the other side. That's going to cause it to, if I switch sides, I'm going to switch signs. So it's going to be -5 minus 1 equals 3y. That's -6y, and -6 equals 3y. Divide by 3. -6 divided by 3 is -2. equals y. So I can plug in -2 for my y coordinate point in my ordered pair. Okay, the y part of the point. So then let's look at, okay, well, what is my x-intercept? Well, remember my x-intercept, I have to have a 0 in the y spot. So how do I do that? Well, I'm going to substitute 0 right here for where the y is. So I'm going to rewrite this equation. 4x minus 1 equals 3 times 0 plus 5. Okay, 4x minus 1 equals 0. I don't need to write that 0. You know 3 times 0 is 0 plus 5, so it's just a positive 5. I want to move this to the other side. 4x equals 5. If I'm switching sides, I want to switch signs, plus 1. So 4x equals 6. All right, well, what's happening to the x? It's being multiplied by 4, so we have to divide by 4 here. And we're left with x equals 6 over 4. Well, that's not reduced yet. So it is an improper fraction, which is what we usually want, but it's not reduced. So I can't divide 6 by 4 and get a good even integer. So I'm going to divide both of these by 2. So 6 becomes 3 and 4 becomes 2. So my final answer will be 3 halves. So I'm going to put 3 halves right here. So my y-intercept is 0, comma, -2, and my x-intercept is 3 halves, comma, 0. You don't always get what I call pretty numbers in math. Sometimes you get decimals, sometimes you get fractions. That doesn't mean it's wrong. It does mean, let's take another look at it and make sure we're confident in the work that we've done when we want to use a fraction or a decimal. All right, linear equations slope. When we talked about lines, if you remember, we saw many lines going many different directions. Here's an example of a line. Now, when you draw a line on your paper, you want to make sure and you have the arrows at either end, because if you remember from geometry, a line continues on forever and ever in both directions. It never ends. The only thing that we generally call a line that looks like this, that has endpoints, that's actually a line segment. It's only a part of a line, but a line actually continues on forever and ever in both directions. Now, this line right here looks like we would be going down a mountain, whereas this line looks like we're going up a mountain, doesn't it? So they kind of look a little bit different. You can think of a mountain. We generally in America, we read from left to right. So when we draw mountains, we think of a person going up a mountain and going down a mountain. So if you ever see a line that looks like you're going up a mountain, it's going to have a positive slope. And if it looks like you're going down a mountain, it's going to be a negative slope. Okay. That's just a hint to help you remember to check your work when you're looking at it and you're calculating slope, which we're going to get into just a moment. You can easily look at the graph and see, well, does that make sense? All right. So what we have to do is just count the change. That's the first way we're going to look at how to calculate slope. We're going to look at a graph, pick 2 points, and count the change between them. So here we have a change in y and change in x. If you remember this was in our vocabulary. We talked about this. Slope is change in y. Remember, it has a triangle sign, change in y over change in x. Okay, so we can count change in y and change in x. So here's the 2 points that were chosen to calculate this slope. So the change in y from this point to that point, let's count 1, 2, 3. So it's going to be 3 change in y. Now the change in x from this point to this other point is 1, 2, 3, 4, 5. 5 on the bottom. So m is going to equal 3/5. Oops. Here you go. We have it written off to the side there as well. The process that we just went over was also called, very commonly you'll hear it known as rise over run, because when we counted up, that's rising, and run is always to the right. However, sometimes if you are choosing your own points and you're counting stuff out, say we are going between this point and this point, sometimes you might have a tendency to want to count downwards instead of upwards. In that case, you would do that as a negative. And then anytime you're going to the right, it's positive. But if for some reason you were to count to the left, that would be a negative, okay? So the main things to remember here are, if you're counting it out yourself on a graph, if you're going up, it's positive. If you're going down, it's negative. If you're going to the right, it's positive. If you're going to the left, it's negative, okay? Here we have an example for us. There's multiple points on here, but what I'm going to do is just choose 2 of them, okay? So here I want to do the change in y, and I'll go down this time. So 1, 2, I went down to -2 over, if I just went 1, that'd be -2 over 1, so m equals -2. Well, let's look at this. What if I chose 2 points that weren't right next to each other? Would I still get the exact same thing? Well, let me choose this point and this point. Those aren't exactly next to each other. And this time I'm going to count up instead of down. 1, 2, 3, 4. Okay, that's a climb or rise of 4. And then I'm going 1, 2 horizontal. But since I went to the left, that's -2. Okay, well, now I'm going to need to reduce this. There's only one negative. That's an odd number. So I know my answer is going to have a negative in it. And then 4 divided by 2, well, that's just 2. -2, that's the same thing I got over here. So it does not matter which 2 points you use. As long as you calculate the slope as change in y over change in x, you're going to get the same number once you've reduced it. Here is another example for us. Let's go ahead and do some change in y. 1, 2, 3, 4. Okay, that's our y change. And then our x change is going to be 1, 2, 3, 4, 5, 6. Okay, so I went up 3, and then I went to my right 6. So that looks like it's going to be 1/2. And if you notice, doing it this way, I have a positive line, and with this one I had a negative line. So my slopes definitely checked out based on the information that I know. All right, so here you've got some work you can do. Go ahead and pause the video and calculate the slope using rise over run. You don't need to know any points here. It just goes ahead and tells you what the change is for you. All right, welcome back. Rise over run. Rise is 4, run is 2, and that equals 2. So m equals 2. Here we go. We've got 3 over 5. That can't be reduced at all, so m equals 3/5. Here we've got a rise of 3 over a run of 3. That's going to equal 1, so m equals 1. And here we have a rise of -4 over a run of 2. An odd amount of negatives means my answer is going to be negative. 4 divided by 2 is 2. And here we have the answers just to verify that we got them correct. All right, so we went over slope by counting, by looking at it visually. But what if you just know some coordinate points, but you don't know, you don't have it graphed in front of you? It's too big to graph. Or even just when we were looking at one of those, it was a rise of, I think, 3, but a run of 6. To count that all the way out sometimes can get taxing. It can just be annoying. So there's another way to do it. When we talk about change of something, that indicates a subtraction problem. So if we have change in y over change in x, That's the same thing as y1, excuse me, it's usually written as y2 minus y1 over x2 minus x1. So we have a mathematical way of producing the exact same information without having to go and count all the way over. So in order to do this, you have to identify something as 0.1 and something as 0.2. And whatever you identify as 0.1, it goes in this second spot. So you're going to put the y on the top and the x on the bottom. And whatever you identify as 0.1 goes in this first slot here. The y goes on the top and the x on the bottom. If you notice, the ordered pair is still a pair because you still have the same x and y paired up here, but instead of being next to each other in an ordered pair, you have them as a fraction one over the other. So here we have an example. Find the slope of a line that passes through the points 15, 8 and 10, 7. And so I've already gone ahead and written out for us. We're going to call 15, 8.1 and 10, 7.2. So I'm going to write up here 0.1, and I'm going to choose a bolder color here. We're going to put this one as 0.2. So I know that I need to have y2 minus y1. So I'm just going to look at 0.2 first. I'm going to start with that. The y value is 7 and the x value is 10. If you notice, I go ahead and write the paired values at the same time. I'm going to put the y on the top and the x on the bottom. Then I know I'm going to have a minus and a minus. I know that that's going to be there no matter what my next numbers are. It may change if one of my numbers in the next point is negative. This will change to a plus instead of a minus, but I know I need to start with a negative there. All right, so let me look at 0.1. Okay, it was on the top is the y, so I'm going to put 8 here, and on the bottom is 15. All right, so 7 minus 8. Ooh, that's a -1. Okay, 10 minus 15, that's -5. Okay, well, two negatives, that's going to make a positive. So my slope is 1/5. Oops. I want to go ahead and show you that it doesn't matter which one you choose as 0.1 or 0.2. Let's pretend this time that, let me erase this. Let's call this 0.1 and this one will, well, we already did that. We're going to go back and call this one 0.2. 0.2, okay? And this one we're going to call 0.1, okay? So if we do that, we know that 0.2 comes first and the y is on top, 8, and the, oops, I'm going to erase this because I want to keep my colors the same. 8 on top, 15 on the bottom. And I know I'm going to have minuses there afterwards. So 0.1 here, 7 is going to go on top and 10 is going to go on the bottom. So 8 minus 7 is 1 and 15 minus 10 is 5. So m equals 1/5. No, oops, I put 1 over 5, 1 over m. It should say 1 over 5, 1/5. So we've got 1/5. No matter which way we subtract it. The main idea is as long as you keep the pairs together, you'll be fine. All right, so I've got 3 questions here for you. Go ahead and pause the video and then unpause it when you're ready to go over the work. So here I'm going to label this just 0.1 and 0.2. So 0.2, I'm going to put 5 and -1. Put my minuses there. This time I've got some negatives for 0.1, okay? So I've got a -10 here. Well, if I put -10, I can't subtract a negative. Instead, that turns into a positive, okay? So it's going to end up being a positive 10. And here I've got a -5, so the same thing is going to happen. I can't subtract a negative, so it turns into a positive 5. All right, so 5 plus 10 is 15. And -1 and positive 5, they're 2 different signs, so we're going to find the difference of the 2. The difference of the 2 is 4, and the larger value is positive, so our answer is going to be positive. 15 over 4 is what m equals. There's no way to reduce it any further than that. All right, so what is the slope of the line that passes through these 2 points? Let's call this 0.1 and this 0.2. So 0.2, we're going to start with 8 on the top, 3 on the bottom, subtract these. And then here we've got 0 on the top and 1 on the bottom. 8 minus 0 is 8. 3 minus 1 is 2. 8 divided by 2 is 4. So our slope is m equals 4. All right, so here I'm going to call this one 0.2 this time, and this one 0.1. So what is the slope of the line that passes through these points? We always start with 0.2, so, and y goes on top, so I've got 2 on the top, negative 4 on the bottom. I'm going to put subtract signs down. And then the 0.1, I'm going to put negative 3 on the top, so my negative becomes a positive. And then positive 3 here at the bottom. So 2 plus 3 is 5 over negative 4 minus 3, same sign. We're going to combine 4, 5, 6, 7. And since they're both negative, we're going to put a negative in the front. Well, if we have a negative on the bottom, since there's only one negative, there's a positive and a negative. That means our answer is going to be negative. Now 5 over 7, I can't reduce that at all. So negative 5/7 is my slope. And that is it for today. I'll see you back for the next lesson in just a moment.